Hi everyone, welcome to our presentation. My name is Oğuzhan Kaya and I'm mechanical engineering 4th class student. In this project there are 4 students are working together and on this page you can see the names and departments of my workmates, also our supervisors. Today me and my friend going to talk about artificial intelligence based deep learning studies. In this presentation we will examine other studies in detail. In this work, a deep learning approach is planned and actualized to display a flexible homogenization structure property linkage in a high differentiation composite material framework. More specifically, the proposed deep learning model is utilized to catch the nonlinear mapping between the three-dimensional material microstructure and its macroscale stiffness. In this work, an intelligent model based upon the neural network technique has then been developed to estimate the total sulfur output of this process. The three-layer feed-forward neural network developed consists of 5 neurons in a hidden layer, trained with back propagation gradient algorithm. The predicted amount of residual total sulfur is in very good agreement with the corresponding experimental values revealing a correlation coefficient of greater than 0.99. In addition, a genetic algorithm has been employed to optimize values of total sulfur as well as reaction conditions. In this work, they worked on recent progress in electronics seeking, multimodal force sensing, temperature and humidity detection, as well as self-healing abilities are also exploited for multifunctional electronic sequence. Other recent progress in this field includes the integration with high-density flexible circuits for signal processing, the combination with wireless technology for convenient sensing and energy data transfer, and the development of self-powered electronic sequence. There are 3 figures. In figure 3, you can see schematic illustrations of 3 common transduction methods and representative devices. In fourth figure, there are different strategies to achieve stretchability with the help of 2-dimensional nanostructures of silicon. In this work, this review begins with a presentation of the combination and properties of MAXIMs. At that point, the advancement of MAXIM polymer layers will be talked about, which means to sum up different methodologies of manufacturing MAXIM polymer films and their captivating properties. The focus then turns to their exciting potential applications in various fields such as filtration, electromagnetic interference shielding, energy storage devices, wearable electronics, and etc. In this work, they present the perspectives on the characteristic properties of graphene and its surface design. Worried about the transduction systems in biosensing applications, they explain practical synthesis techniques along with prospective properties of the graphene-based materials, which include the pristine graphene and fluctualized graphene. Briefly, they aim to produce graphene-based materials and biosensors. Thank you for your attention. Now my friend will continue.
Hello, I am Çağatay. I will continue. Here they show the artificial graphene throat induced by a smart laser that can not only produce sound but also detect sound in a single unit. Here they define a class of ferroelectric field effect MUKIS transistors made of a 2-dimensional semiconductor on a thin film for optoelectronic synaptic devices called PST. In this analysis, a total of 28 transition metals expect lanthanide sequence are shown in period 4 to 6 of the periodic table. It has been examined in its periods. This article provides a detailed overview of the basic understanding of electronics that emerge with 2D TMDC contacts and channel engineering using these various approaches. In this study, they systematically investigate the optical and optoelectronic properties of artificial heaps of molybdenum disulfide, tungsten disulfide, and black phosphorus atomic layers. Here they present the latest research from various techniques available in transmission electron microscopy to characterize layered TNDs structurally and analytically, and briefly compare the advantages of TEM with other characterization techniques. In this mini review, they highlight some recent efforts to connect the communities of machine learning and nanoscience by focusing on three types of interaction. Firstly, the use of machine learning to analyze and extract new insights from large nanoscience datasets. Secondly, the use of machine learning to accelerate the discovery of materials, including the use of active learning to guide experimental design. And thirdly, the nanoscience of MEMS-led devices to manufacture machine learning made hardware. They conclude with a discussion of challenges and opportunities for future interaction between researchers from the nanoscience and machine learning. Here they are used theoretically to adapt advanced, optimistic and unlabeled machine learning to predict that 2D materials are likely to be successfully synthesized.
Our sample was synthesized and reconstructed by atomic force microscopy. The image that has XQD file format is obtained. At this point, the reconstructed image is going to be mentioned as the original image. In order to open XQD file and label nanosheets on it, a graphical user interface is constructed. By clicking on Browse File button, one of the original images can be selected and opened in the frame. If the color intensity of the image is not suitable to observe nanosheets, using Adjust Color Level slider can provide a more appropriate color intensity that makes nanosheets more visible. Moreover, not only adjusting the color level, but also zooming on the image ensures to observe nanosheets clearer and also closer. Since a convenient image is obtained, labeling nanosheet process can be performed by clicking on Select Region button. After labeling operation is done, by using Save button, the image is saved with MAT extension, which is in the binary data container format that MATLAB uses. Therefore, the labeled image is saved as a mask, which means it only has zeros and ones. The places that contain nanosheets are marked as 1, and the rest of the image is marked as 0. In order to simplify nanosheet detection on the original image, the image is divided into 32 to 32 matrices. On each matrix, 9 graphical parameters are applied. Then, the numeric values of these parameters are kept as inputs in a collection. Simultaneously, the masked image is also divided into 32 and 32 matrices. By considering the values of matrices, each matrix is marked as 0 or 1. If the matrix contains even a single 1, that matrix is marked as 1, which means it has a nanosheet in it. At this point, a multiplication between the matrices of the original and the masked image is performed. As a result of that, the numeric values of the places that contain nanosheet are obtained. Therefore, the data is ready to process in artificial neural network. For processing the data, an interface in MATLAB named Neural Network Start is used and pattern recognition app is chosen. Then, for defining the pattern recognition problem, input and target data are given to the network. Furthermore, the percentages of validation and testing data are arranged. In this project, 80% of training data is preferred. Although the number of hidden neurons also can be arranged, after some tests are done, we decided to continue with the default number, which is 10. Eventually, the network is created and it is trained to classify the inputs according to the targets. If the result is not satisfying enough, the model can be retrained. On the right side of the page, the error percentages can be seen. As a result of all these processes and numerous practices, the accuracy rate is concluded between 89 and 94%. In conclusion, the expectation of the project is matched with the results. Thank you for listening to us. We are ready to receive your questions.